Hey, what's up, people? My name is Fred, and you're welcome to my YouTube channel. So today I'm going to be introducing you to a topic called or titled Interpenetration of Solids. Okay. Now, interpenetration of solids application can be found in most engineering industries, oil and gas industries, water corporations, even at homes. Okay. Now, if you check the PVC network of your pipes, of the PVC network of your sink, your toilet, and stuff, okay, the network, you'll see where pipes interpenetrate, okay, one interpenetrating the other, all right. So these are, and many more, are areas where you can find the application of interpenetration or intersection, if you like, of solids. So what I'm going to do now is I'm just going to be introducing to this topic, and I will treat one example, but then I would like to explain further using AutoCAD, all right? So you would have a clear picture of what I'm talking about when it comes to interpenetration of solids. All right. Okay, so I want you to look at these pipes that are here, all right? Look at them, all right? Now these are, let me zoom in a little bit. All right, okay. Now these are pipe interpenetrating each other. So we'll just quickly do an explanation. Now, if I move to the front view, okay, so you can see it very well. All right. Now look at these two pipes. Let's say this is pipe A, or let me say this is example A. Now in this example A, this is pipe A. This is pipe A, and this is pipe B. This is example 2, and this is pipe A, and this is pipe B. All right. Now if you look at this pipe, you'll discover that the diameter of this pipe is smaller than of pipe B, is smaller than pipe A in this example. And the diameter of pipe B here is equal to the diameter of pipe A. Okay, so these are cylindrical pipes, actually cylindrical. Now, the things that you're going to look out for, or the examiner is going to look out for you, or the most likely question you're going to be asked is to develop this pipe A, all right, and also develop this pipe B. A and B, all right, that's it. So when pipes are connected in this form, you say they are interpenetrating or intersecting, all right. Now you could have a cone, all right, interpenetrated or intersected by what? A pipe. Now you could have a hexagonal pipe intersecting another hexagonal pipe, or a square pipe intersecting a square pipe, as the case may be. So it varies. You could even have a sphere intersecting a cone, and so on and so forth. Now, these are the simplest case you can ever have. So let me just quickly make mention of something. Now, whenever a pipe is intersecting another pipe, there is a joint a point where the pipe joins the other one, like pipe A joins pipe B. Now, that line, let me zoom in a little bit. You see this line here, or curve, if you like, is called the curve of intersection. All right. Now for pipe B, you also see it here. It's called the curve of intersection. Now here is something you must understand about pipes that are of equal diameter and different diameter. Now, number one, if the pipe are of different diameter, this is a cylindrical pipe, different diameter, the curve of intersection will appear as a curve. Can you see it? It's a curve. You could see it as a curve. Now, if I should move this a little bit, you will be able to see that very well. Can you see that? Okay, so this is a curve actually. All right, so back. Now, if the cylindrical pipes are equal in diameter, you see this curve of intersection, this, okay, from a distance, it will look like a straight line. Can you see it? It looks like a straight line, but in reality, let me move that, it's actually a curve. Can you see that? It's a curve. You understand? In reality, it's a curve. Hope you can see that very clearly. Okay, it's a curve. All right. So, but let me go back now. If you look at the elevation, it will look like a straight line. So there is this question always that is associated with interpenetration of solids, that when two cylinders of equal diameter intersect each other, what is the curve of intersection? A straight line. B, a curve. The answer is a straight line actually, but in reality it's not a straight line, but it's looking like a straight line. Let me further broaden your knowledge on that. Now look at this top here of this pipe. All right, this part of this pipe you're seeing is looking like what, a straight line, isn't it? But it's actually a curve. So if I move this, you see, it's a curve. Do you understand? All right. But because you're viewing it with your eyesight perpendicular to the surface of the pipe, like the elevation is looking like a straight line, so that's exactly what's happening here. Okay, so it looks like a straight line. All right, so that's what I need you to understand about interpenetration of pipes when they are equal cylindrical pipes and when they are what? Unequal cylindrical pipes. So I'm going to treat example number 1, and it's going to have to do with equal cylindrical pipes. Okay, so here is a typical question. Now this is pipe A and this is pipe B. They are what? Intersecting each other. All right. So now we assume that this pipe is intersecting this other pipe here at the mid, like if this is 80, all right, just at the center, that's 40. That's where it is what? Intersecting. Okay. In other words, what I'm trying to say, the distance from here to the top and from here to the bottom, they are equal. All right. Okay. So how do we go about this? Now the question says, now you are going to have to reproduce this drawing. Then number 1, you would draw the what? The plan. The interpenetration. Now you're going to draw the plan. When you view from the top, what are you going to see? So you're going to draw the plan. Then the curve of intersection, I'm going to show you how to do that. That's where both pipes connect, that line, that curve. Okay, that point where, or that line where it joins the other one, that's the curve of intersection. Then development of A, we're going to develop this pipe A, and development of B, we're going to develop pipe B. Okay, so the first thing we're going to do is to reproduce this drawing here using the dimension given. All right, so to be able to do that, you should first of all draw a straight, or if you like, a center line. Okay, just draw a line like this first. I hope that is clear. A thin line, not a thick line. So because I'm using camera, let me make it a little bit visible, but this is actually a thin line, not a thick line. All right, so what you do next is drop a perpendicular somewhere. So align your set square. All right, I'm going to adjust it a little bit. So adjust. So I'll bring it down and look for a convenient point to drop a perpendicular like this. Okay, so that's it. So what I'm trying to draw now is the bottom here. All right, so now this is what? 50. So if this is 50, I'm at the center, I'm going to measure 25 to the left and 25 to the right, making 50. So I'm going to have to get my ruler and so let me adjust this a little bit. Okay, so this is 25, this is 0, and this is 50. Okay, and so this is 25, so that's the midpoint. So from here to here is 50, so 25, 25. Okay, so what I'm going to do is I'm going to drop a perpendicular with a thin line. So I will align my set square with this vertical line. So I will transfer a line here and draw thin line upward, transfer a line here and draw thin line upward. Right, so from here we are told that this is 80. I'm going to measure 80. So this is 80 here, that's 80. So I'm going to transfer this line to the point where we have what? 80, and that's it. All right, so what I did was that I got rid of this excess line here. Okay, so what I'm going to do is I'm going to look for the center 80. Here it is. So this is the center. So this is 80 and this is 40, the center. All right, so I'm going to transfer line, this horizontal line here, to where I have 40, a center line. I'll just draw a center line through. Okay, that's it. So remember, this other pipe is 50 as well. So I'll place my ruler here again, 25 up, 25 down. So this is 0, 0, 1, 2, 2.5, that's 25. Okay, so this is 0, this is 25, and this is 50. All right, so these 2 points, I'm going to transfer lines there. Align your set square transfer line to this point here, just draw, transfer line to this point, and you draw. Now we are told that this distance is 35, so I'm going to measure 35. That's 3.5. So from this is 3.50. I will dot 0, and I will transfer vertical lines to this point here. Here I have 35, and I'll draw a line up. So that's it. So I'm going to erase this. Okay, so it can be clear. It can look exactly like this. All right, so what I'm going to do, I'm going to use thick line to complete this. Okay, so the diameter is 50. So what we're going to do is we're going to draw a circle of what? 50 diameter. But to draw a circle of 50 diameter, you need to stretch what? 25. So this is 25, okay? So this line you drew at the beginning, just needle at any point. Make sure you give a little bit of distance. All right, needle at any convenient point of your choice. All right, and draw a circle representing what? The plan of pipe A. All right, you know, when you're viewing from the top here, you'll be seeing this as a circle. I showed you in the video, sorry, in the AutoCAD that I displayed earlier. So that is this, okay? Now this one will remain the way it is, okay? It will still look like what? The way you're seeing it. So what you're going to do next is you transfer lines to this point, moving this way. Now, first of all, draw lines from this point, thin lines here, down, thin line, okay? The transfer now for this pipe, all right, you want to draw it because it's intersecting. So align your set square, transfer to this point here, draw a line to touch that point, and transfer to this point here. I hope that's visible on the camera, okay? And that's it, okay? So what I'm going to do is I'm just going to draw this line because it will be visible. I'll draw these thick lines. All right, so this circle is also a thick circle, excuse me. All right, so now transfer lines from here. Again, let me take this one here because this one is longer. Okay, transfer it to this center here. All right, and draw a line through to cut this line here, and just stop there. Now, with your 25, okay. Now, if you view from this part, you're going to be seeing this circular, you know, pipe here. So we're supposed to draw a circle here. We're going to divide it into 12 equal parts, and we'll move the points into what? This particular one. We'll do the same thing here. We'll move the point, but we don't need to draw a full circle. If we draw half a circle, that will just be enough. So what you're going to do is just needle here and draw half a circle. Thin lines, not thick lines. So this is already 25. If you needle here at this point, this is 25. Can you see that? Okay, and another 25, making the diameter of the circle. So draw a semicircle like this. Just do the both of them. Okay, remember this is 25. It doesn't change. Now divide this into 6 equal parts. So with this radius 25, needle here, cut this top here, cut the bottom, needle here, cut this circle at this arc at this point, needle here also, and cut this. Remember to keep this fixed as 25. That's the radius of this circle here. So do the same thing here. So when you're done with that, you label here 0, 1, 2, 3, 2, 1, 0. Now let me mention something. Now you see this 0, when you're viewing from the top, you know this is where your eyes are. Okay, when you're viewing from the top, you'll be seeing this 0 directly on the top. That is, when you're viewing the plan, this 0 here is directly on the top. All right, that is here. So this 0 comes here because it has changed. Do you understand? All right, so this becomes 0, 1, 2, 3. This numbering is very, very important. Do not mix it up with this one, okay? Like, do not confuse the numbering here with this one, because When you view from W, this becomes 0, 1, 2, 3. If you view the pipe, so this becomes 1, 2, 3. Okay, so when you're done with this, align your set square with any horizontal line. Okay, transfer to 1 and draw thin lines. 2, 3 has been drawn. Move to 2 again. Make sure you are precise with your drawing and transfers, okay? Transfer lines. I will also transfer lines down here also, but I want to keep this video short. Okay, so this is it. So remember 0, 1, 2, 3, 2, 1, 0. At this point, it becomes, here becomes 0. This top here, 0. That's it, this top. 0, 1, 2, 3, 0, 1, 2, 3. Don't miss that. Okay, now what I'm going to do next is look at, now after transferring, now these lines are transferred, I also transferred here, so but let it touch the circle just on the circumference of the circle. All right. Now note that 1 and 1, they are the same. If I draw a line up, it's the same thing as 1. So, but I'm not going to draw a line from the bottom here to the top. So this is 2, this is 2. They will be on the same line if I draw a line up. 3 and 3 is already drawn. All right. But I just want to take it from the top only. But you should understand that this is also representing this one. This is representing this one. That is 2, 2. All right. 1, 1. This is the point 0. So I'm going to draw lines up. So align your set square like this. Start with what? 0. Now 0 will match with this point. Definitely. Okay, I ought to have done that from the beginning. So let me just fix this part. All right. So that's it. Now this is already existing. Now I will transfer to this point as well, and I will draw up. Now you can see that this one is matching with this one, but I'm not going to draw it all the way from the bottom. I'm only going to focus on the top. If you draw it from the bottom, there's no problem. You are still okay, but I don't want to crowd this with lines. So I'm just going to draw up. All right. Transfer to this next point here, where 2 is touching. Draw lines up. Okay, I hope that's clear. Good. Now we're going to match lines. Now this is 3, right? And this is 3. So this line is representing 3. So as you're moving, you are going to match it with where you have line 3 also. So see this. This is line 3, right? Both of them are the same. So I move up. Where is line 3 here? This is line 3 here. They are meeting here. So both lines are meeting here. So I have a point here. All right. Now let's check. Now let's go to 2. Now remember, these 2 and these 2, they are the same. So if I'm moving these 2 upward, all right. Now I'm also referring to these 2. Sorry, to these 2 as well. So something like this. All right. So from these 2 upward. So if I move 2, I'm also going to what? Intersect with wherever I see 2 here. Remember, this is the only point where I saw 3. So this is 2. I'm moving. Where is line 2? This is line 2. They are intersecting here. This is a point. I will continue still on this 2. There is still another 2 here. They are intersecting here. Can you see that? And this is another point. That's it, point 2. Now the last one, which is it the last one? Now 1. Second to the last, 1. Now don't forget again, 1 and 1. They're on the same line. All right, this is 1. This is 1. So they're on the same line. So I will intersect it with wherever I see 1. All right. So if you move 1, this is line 1. Can you see that? It's intersecting at this point. Continue. There is another one here. Continue up. This is 1. Intersect. All right. Now the last one, which is 0. Now if you move 0, this is 0 here. So it's already intersecting here. If you continue with this line also up. So let me just draw a thin line there. So still on 0, moving up, another 0 here, intersecting. So this is it. So now you will discover that this will be a straight line. If yours is not a straight line, then you made a mistake. It should, but it's actually a curve in real life. So you draw it. This is the curve of intersection you have been asked to look for. So this will just go through all the points. It will go through all the points. Can you see that? That's it. So with that, we've already answered this question. Okay. Also, we've answered the plans because this is the complete plan. So we've also answered this one, plan. We've drawn the plan. And we've drawn the word. We've copied this. So what we're going to do next is we're going to develop this pipe A. This is pipe A. And this is pipe B. Can you see it? Now let us focus on pipe A. How do we draw the development? Very simple. Now extend this line at the base with a thin line. Okay? And also extend this, but I would like to transfer it, so I'll be very, very sure it is parallel to the top here. Extend with thin lines, please. Okay, so we're good. Now what we're going to do next is choose any point where you want to start your development. Okay, any distance. So you align your set square with a vertical line here. And just move to any convenient point of your choice. So I would like to start here. That's the thin line. So I want to start my development from here. I just give any distance of my choice. Now, let me say XX is the seam. I'm using XX as the seam, although it wasn't stated here, but let me just do that. So you use here XX as the seam. Then for this pipe, you use, let's say, YY as the seam. So this we are going to use as our seam for this other pipe, YY, all right? So that means the seam is where you're opening from. If you don't know what seam is, go check my video on development. I explained what seam is all about. Okay, so now what you do next is take any of these divisions. All of these divisions you're seeing here, they are all equal. So from 0 to 1, 1 to 2, 2 to 3, they are equal. Just take one of them. Or if you like, you can come down here and take from here. The same thing. So just take this. Can you see that? They are all the same, as you can see. Take one of them. Now needle here and step off 12. Because this is actually 12. This is half of a circle. There is another half, making it 12 equal divisions, okay? So I'm going to step off 12 equal divisions here. So this is like 1, 2, 3, up to 12. Okay, so this is 12 equal divisions. So what I'm going to do next is I will align my set square like this, and I will transfer lines to all 12 divisions. I'll draw thin lines, not thick lines, thin lines. Draw them up. That's 1, this is 2. This is 3, up to 12. Okay, so that's it. So what I'm going to do next is, you see this point? This is 0, 1, 2, 3, 2, 1, 0. All of these lines, I'm going to draw them, all right, to intersect all these lines that are here. I hope that's clear. All right, so align your set square with the horizontal and draw. I'm going to extend them later, so draw this point here. So I'm going to draw all the lines. Okay, so that's it. All lines drawn. Now, let me say something. I'm actually supposed to divide this circle into 12 equal parts, but there is no need. Why? Because the two pipes are equal in terms of diameter. So I may as well use these divisions here. So that's what I did here. I hope that's clear. Now, if I had divided this circle into sorry, there is a mistake with my numbering here. I am supposed to follow this numbering. All right, like 0, 1, 2, 3, 2, 1, 0, 1, 2, 3, 2, 1, 0. All right, so I'm going to correct that real quick. Okay, so that's it. It's been corrected. 0, 1, 2, 3, 2, 1, 0, 1, 2, 3, 2, 1, 0. But you must ensure this is 12 equal divisions. Okay. Now the reason why I have to number like this is because of the numbering that I have here. All right. Now what I'm going to do is that maybe I should just divide this into 12 so you will understand exactly what is going on here. Okay, so I think this is better. Now, I believe you know how to divide the circle into 12 equal parts. If you don't, check out my previous uploads, okay, on development. You would see where I explained. All right, so you divide into 12 equal parts, so that's it. Now, this is for clarity purpose. Now, you know you are developing from here, so please be very, very careful. All right, so you see this 0 here is this one here, because you are moving. This is coming, and this is a circle. So this is like 0, 1, 2, 3, 2, 1, 0, just like that. All right. So this one is this. This one is this one. This 2 is this 2. This 3 is this 3. This 2 is this 2. This 1 is this 1. And this 0 is this 0. So take note. All right. So this one again, 1, 2, 2, 3, 3, 2, 2, 1, 1, and 0, 0. All right. So don't confuse this 0 for this one. Remember how I moved and I got here. So you see this part of this pipe will be opened. This pipe A will be opened. So this opening is actually going to be at the center here. So now let's go. Now you see this. This is what? 0. So wherever you see 0, you dot 0. So if you trace, this is 0 here. Remember, this 0 and this 0 is the same thing with this one. All right. So this is 0 on this 0 now. So you move. This is it here. This 0. You dot. Now if you continue also, you see another 0 at the top. You move. Continue also with here. Here you dot. That's this 0. Then this is 1. Remember, this 1 and 1, there are two of them. That is left and left and right. Look at it here, left, right. That is the one you're seeing here. So move to 1. This is 1. Intersecting here. Continue. There is another one here. Intersecting here. Then there is another one at the top. So you continue on this same line. So 1 here. Intersecting here. Still, there's another one here. This one. Intersecting here. All right. So the next one is 2. So remember again, this is 2, 2. So this 2 and this 2. So this is the 2 here. So you move, they will intersect here. There is another 2 here. Continue, intersect. Move up. There is another 2. Still on this are 2 here, here. Okay. Still on this 2, they will intersect here. And you move. This is another 2 here. They will intersect here. And finally, we have 3, 3 here. So you move here. This is our 3, 3. Okay. So this 3 will intersect here. And continue with this 3. They will intersect here. So you could see the whole of that. All right. So you join this curve using your what? Your flexible curve or French curve or broomstick, whichever one that applies. All right. So connect this curve. Okay. So with thick lines, you connect this. All right. With a curve. Then also draw this outline. It's part of the development. Thick. Okay. So that's it. All right. Development of pipe A. This is it. Be careful not to join this, okay, with a thick line, okay, because this is separate. All right, so what we're going to do next now, we're going to develop pipe B. So we're going to develop this way because this is the seam XX. Remember, this is the seam XS, sorry, YY. This is the seam XS. We've developed this. We're going to develop this one here. All right. Okay, so what we're going to do is we're going to extend this center line here. All right. We're going to extend it up. So extend up like this with thin lines. Now remember, this pipe starts from here and ends here. Don't make the mistake of ending the pipe here. And the pipe does not end here. Some students make the mistake of drawing this line up and they develop it all the way to this top. No, it's wrong because this is where it ends. So this is where it stops. All right. So we also have to align our ruler here, or if you like, you can transfer lines and draw this one up. Okay. So when you're done that, remember these are thin lines. Now look for any convenient point where you will start your development. So I'm just going to pick a horizontal line from here. Let me pick the center line here. Transfer, give yourself any distance of your choice. Okay, and draw the first line. Okay, once again, remember both pipes. Now don't forget, I stepped off 12 equal divisions here. I used this, one of the divisions, okay, to do that. Now I didn't have to bother because the two pipes are equal in diameter, so I could actually use any one. Had it been they were different in diameter, I cannot use the division of this one to step this one off. No, I will use the division of this one to step this, or I will use the division of this one to step this. So I just thought to mention that. So take one of these divisions, they are equal, and step off 12 equal divisions here. 1, 2, 3, up to 12. All right, so here are the divisions. So what you do next is align your set square with a horizontal line, and transfer lines here. 1, 2, up to 12. Okay, so there it is. Now do not forget, once again, this is 0 1 2 3 2 1 0 1 2 3 2 1 0. That is 12 equal divisions, and I started with 0 because the same starts with what? 0 1 2 3 1 2 3 2 1 0, and so on. So what you do next is you're going to have to transfer lines. Just a minute. Okay, so you align your ruler with a vertical line. All right, and you transfer lines to all of these points where you have the intersections, that is 1 2 and 3. So you transfer lines across, draw the lines across to this point here where you have the point of intersections, and finally here. Okay, so that's all. So now remember again, this is numbering. The numbering is very, very important. Okay, now we're going to match numbers again. So remember, this 0 is this one. Okay, this 1 is this, 2 2 3 3 2 2 1 1 0 0. It's repeating. I told you it's a complete circle. The 1 1 2 2 3 3 4, and so back to this 0. So now this is 0. Do not forget, this is 0 and this is 0. So we trace, and wherever we see 0, all right, on this line, we will dot. So trace this. Now let me use my ruler so you'll be able to understand. So I'm talking about this line here, this one. So this is 0 and this is 0. So we move. So there's a 0 here, dot, intersecting with this 0 here, dot. Go. There's another 0 here, dot. All right, move. There is another 0 here, the last one, you dot. I hope that's clear. So we have these 3 dots. Now the next one is what? 1. Remember this 1. This is also another 1. So we move. Wherever you see 1, you dot. 1. This is 1. This is another 1. Continue. This is another 1. I think I missed one. Okay, hold on. 0 1 2 3 2 1. Okay, 0 1. Yes, and another 1 here. Okay, so that's it. Then the next one is what? 2. This line here. Okay, do not forget there's another 2 here. So wherever you see 2, just dot 2. So this is 2 dot. This is another 2 here, dot 2 dot 2. You dot. I hope that's clear. Then finally we have 3. So wherever you see 3, so this is the line 3, line 3. So wherever you see 3 here, you dot. Intersect 3. This is 3. There is another 3 here, just those 2 points. Good. So can you see this curve? This curve. Join them with what? A French curve or a flexible curve. Okay, so that's it. Connected. Make sure you do not make mistake with your joining. So we've joined that. Now we're going to draw these parts, thick lines, to complete the drawing. Okay, so that's it. The job is completed. So this is how you develop 2 pipes, 2 equal pipes with the same diameter. All right. You can rewind this video, play it all over and over again if you do not understand. Now this is development of pipe B. This is development of pipe A, and this is the elevation, and this is what? The plan. All right. Thank you very much for watching. Now do me a favor, just hit the subscribe button and the like button. The next video I'm going to be uploading is going to be on intersection of a smaller pipe. Okay, that is a pipe with a smaller diameter as against a bigger pipe. Then also I will be uploading more videos on pipe like this one. They are intersecting at 90 degrees. Some will be intersecting at what? So at an angle other than 90 degrees. Do you understand? I'm also going to be dealing with such in subsequent upload. Thank you for watching. Don't forget to always tune up to this channel for more videos, and ask questions where you do not understand. Just drop your questions on the comment section. All right, do have a lovely day. Bye.